It's time for some amateur hour with a camera again. So I'm going to talk about my electric car conversion, and I'm excited to say I finally actually made some real progress, and it's operational now. It can actually be driven. So it's been, I would say, 2.5 years, shamefully, the conversion time. To get to the point I'm at now. I have basically all the critical systems going. I have a motor to drive the car spinning with its inverter, and I have a DC to DC converter, a power steering pump, a brake booster vacuum pump, and a cooling system. So it's been a long process to get to this point. It's a lot of work, but I can show you what the progress has brought. It's reasonably impressive, actually. It's not too far from getting the front wheels of the car off the ground as I'm driving, so it's very powerful. It's amazing. So I will show you what I've got to do to start this thing up. There's not too much to it. At the moment I still haven't connected the cooling pump to the main power of the car. So I've still got a just a little 12-volt battery here that runs the cooling pump. It's the only thing that's not finalised yet. So just start that up, and I'll show you what we do to start this up. So here we are in the car. I have a normal shifter, automatic shifter, which I've rewired to accept basically a forward and reverse. So if you've got it in park, it will ignore it. If you've got it in reverse, you go reverse. Neutral, it will ignore it. Drive 4, 3 and 2, you will get forward propulsion. So what I'm running is the Generalised Electric Vehicle Control Unit, and that's basically Colin Kidder's pet project. Very impressive coding, I have to say. So that's the interface there. I've actually modified a number of things to make the contactors work a little bit better. I'm using 3 contactors in the car, so one for the top of the pack, one for the middle of the pack, and one for the pre-charge. So I had to modify the code because at startup the CPU basically, or the microcontroller being used, puts out an erroneous voltage and flicks the contactors on and off momentarily. So I've just put a signal from the ignition key to enable the contactors, so they basically can't turn on until the ignition key's in a suitable position. So okay, we'll go ahead and I'll just turn the power to the on position, the key to the on position. Oops. So that's the on position now. It's not to the ignition, or I think it's called the auxiliary position actually, and nothing will happen except it'll give the basically the ECU some power so that it can start up. So we should now see a connection, a Wi-Fi connection. It's all wireless, So there it goes there. You can see in there I have GEVQ, it's called, Generalized Electric Vehicle Control Unit. Oops, what have we tried to connect to there? Here you go. GEVQ, so it's just done a connection. Now we will connect to it, and you can see this is the status of everything here. I'm not sure how clear it is. You might be able to see that. Yeah, it's difficult to say. It's the best I can do with my crappy camera skills, unfortunately. So I'll turn it on, and in the bottom left hand corner you can see DC voltage there, and you'll possibly hear the contactor click on, and the power steering pump, and the voltage is going up, it's pre-charging, and you can hear the power steering pump, which is very annoying. I'm not happy with the power steering pump, it's very loud, but I think that's just how they are, unfortunately. If you don't have a electric steering rack, that's what you're stuck with, a noisy bloody power steering pump. So we are at 376.5 volts, so that's probably 3/4 charged, the pack, and you can see the requested torque there is minus 150 Newton meters. That's full regen braking. That's quite powerful regen braking. I kind of like that. It means you don't have to use the brake at all in the car. So what we'll do, you can see motor temperature there is 19 degrees, inverter temperature 21 degrees. So I'll stick it in reverse. You'll see the gear switch go to 2 is reverse, and I'm going to have to shut the bonnet, I've realised. So we'll just shut the bonnet. And it's windy outside and I don't have the latches on, so I'm just going to tie it up so it can't blow open and wreck the bonnet and smash the windscreen. Camera's going all over the place, I realise that, but tough luck. Okay, so we're back in the car. We're going to back out of the garage. Zoom out. And like I said, total amateur hour, but oh, we're going forward. Whoops. We want to go reverse. Yeah, the power steering pump is unfortunately try not to crash it as I'm backing out of the garage. We've got all sorts of dramas getting out of our garage. It's actually really nice using an automatic transmission shifter. These BMWs are not difficult to figure out what's going on with the shifter. So we're just going to back down. I've got a right of way here that the house is on, so I'll just back down the driveway. It'll help if I turn everything around. I can look where we're going. And I'll just go down the hill. Very difficult to drive holding a camera. Okay, so we're now on the road, completely illegally. No certification with this car, so if we see a cop, I'm not going to be happy, but it should be very unlikely on the street. So I'll put some juice into it there. Now, no brakes, but I'm slowing down at a rapid rate because I've taken my foot off the accelerator. It's just, I don't know if you can hear that noise, it's just the plastic shield on the front wheels rubbing against the tyre there. Now, it'll just roll back if you, it doesn't have any creep mode in this, so if you don't have your foot on the accelerator, it's going to roll down a hill. We're on quite a steep hill here. So we'll have to use the handbrake. I can only use about half the accelerator pedal on this road. I don't want to be caught speeding with an uncertified car and crash it at the same time. That would be all pretty bad. So just coming back into the driveway, I'm not going to go far, and I'll put my foot down on the right of way. Pretty intense putting your foot down when you've got this much torque. It's all on the back wheels too, so there's a bit of weight on the back wheels, so you can't get it to skid, but that's about all I can do. Without crashing into our other car. But okay, so we'll look at, I'll just show you what's changed here. So I have to refresh this page. Oh, we've lost our connection because the computer went to sleep. And we're back again. So the motor temperature now is at 31 degrees. Battery temperature is at, inverter temperature, not battery temperature. I don't have any recording of the battery temperature. The battery temperature will be very cold. It won't have changed. 25 degrees Celsius for the inverter. So it's still nice and cool. I might have to see how it goes up some. We've got a lot of hills here in Wellington, New Zealand. So might have to see how it goes up some of the big long hills. I might need more water in the system. I don't think I need more heat exchanging, but it's possible I need more water in it. But yeah, it's very cool. I'll just hold that there as I go back, and you might be able to see the torque and regen kicking in. So regening now. Very hard to hold it steady while you're trying to drive. But yeah, it's a very nice feeling to drive something that you've been working on so hard for a couple of years. And have it work. It's really working quite amazingly well. I'm very surprised at just how much power it has. It's, you know, like I said, not too far from getting the front wheels off the ground if I floor it. The whole car launches, and the front of it definitely lifts it up quite a lot, so just gives you an idea of the acceleration. It's difficult to portray on a camera, but when you're putting 300 newton meters out, that's a decent amount, and it's 300 newton meters non-stop, doesn't relent. So I'm not going to push it any more than that at the moment. I have 200 amp fuses, 200 amp DC fuses in here, so I think they'll probably blow if I go too much higher. And I'm not too keen on, I don't really need many more power than I have. It's definitely more than adequate for what I want to use the car for, so and it just puts an extra strain on the batteries, and it's not really necessary. Just shorten the life of the cells, and it's expensive. So that is it. I'll just take the ignition key out. Superstitious. I don't want any possibility that the contactors are still on. Bloody shocking video, I know, but it's difficult when you don't have any tripods or. So I can feel these the radiator core I've just used for the radiator. I'll talk a bit about all the parts in here and what I've done to get everything going. I'll try and settle this camera down so it's not so annoying to watch. Alright, zoom that out. So this is just an automatic transmission oil cooler, and I've just welded some ends onto it so I can put some 3/4 inch hose on it, and we've got 3 lines, one for the motor, one for the inverter, and one for the DC to DC converter. I've basically drilled a hole, less water, drilled holes in the 3 outlets according to how much water I want to flow through them. I'm only using one pump to pump the whole system, so I have to have the flow rates correct according to how much cooling I want on each thing. I want to obviously have everything as cool as possible, but we've only got so much volume of water. So that's the cooling system. That's just using a Peerberg pump. They're quite nice actually. I think they do 21 litres per minute, and they have a head of 4 metres, so they do definitely chuck the water through. And you notice when you're driving, even if the temperature spikes up to 30 degrees, it cools down very, very quickly because of the amount of water flowing through the system. So I have a inverter here, and I've got a battery box obviously with a whole bunch of Nissan cells in it. These are the Nissan Leaf cells. I have power steering reservoir here, and a power steering pump off a VW Polo. I reckon it's a bit of a piece of junk, but it was almost free, so can't really complain with that. I'll show you the batteries in the boot. It's starting to get dark here now. So that's the Nissan cells, and I'm just checking how warm they are. None of them are warm. They're very cold, in fact. Just amazingly efficient technology. I've been mucking around with this for a long time now, and I've used about 2 or 3 volts of the capacity. I don't know how many amp hours it's gone down by 2 or 3 volts. I know that's not a measurement of state of charge, or it's a measurement of state of charge. It's not a measurement of how much power I've pulled out. So I have 3 fuses in here. One of them's in the boot, or 2 of them are in the boot. There's one there on this pack. The idea is every time I've got a bunch of cells with a cable on each end, I've used a fuse. And the reason for that is, if you're mucking around with cables, not that you should be, with 2 ends disconnected at the same time, but for argument's sake, if you short the 2 ends of the cables which come off, so this cable here and that cable there, if I short the ends of those together, that's not going to be good if it's not fused. So every time I have a bunch of cells. I've got one bunch here in the spare tyre compartment, one bunch here with the fuse at the top left hand corner there, and another bunch in the front. I just reckon it's a good idea that every time you've got cables coming off these things, to minimise the chances of you causing a massive explosion of sparks and flames, it's probably a good idea to put a fuse on. So that would be my advice if you're thinking of splitting your battery packs up, to use multiple fuses. There's potential for problems, and potential for problems when you're dealing with these battery packs is just not worth the risk. You want to try and minimise as many problems as you can. So basically this boot is pretty much normal size. It's not really smaller. I've not got a spare tyre. I'm going to try and squeeze that in under the back seat. So that's more or less what I have. The motor I'm using is a Siemens motor. I've showed that in one of my other videos. I can show you the cells in the front, if I can get these little screws off. I know I said I had a fuse in the front. I've blown the fuse in the front because before I knew about these contactors clicking on and off, I had a problem. So it's just the lid off. Now, so that's the case for the cells in the front. We have a little box here, and that's got the pre-charge and the front contactors. So it's got a little resistor, or a big resistor should I say, not a little one. I think I'm using 150 ohms, 150 watts, and I'm doing a pre-charge in 6 seconds. Could be faster, but I'm just trying to be nice to the contactors. You don't want to, if you set your pre-charge too fast, you're still closing the contactors with a decent amount of charge to dump into the capacitors. So you may as well close the contactor when there's not much charge left to put into the capacitors, so you don't close them with a high current, make them last longer. The other thing to note, probably the last thing to note, is I have all these little loops of wire, and what they are is wires off each cell, positive and negative, and the intention is to get the battery management, or build a battery management system for it. It's reasonably trivial to do that. There's tons and tons of designs out there. I want to have this thing really well protected and automated. These cells are not worth mucking around with, risking any imbalances, which inevitably will happen, I think, especially when I've got cells in the front of the car and the back. There's long cables with resistance in between, so when you're charging, I think imbalances are inevitable. So you can see in the back I have these original cables and connectors for the battery management of the Nissan Leaf. Some people might know that you can reuse the Nissan Leaf battery management system, but the trouble with it is it's designed to be split into 2 parts that are isolated, and you have to split it in the same way that it was split in the production model in order to use the whole battery management system, because it's meant to be isolated. If you try and use it in the way that wasn't intended, the circuit board will be damaged. So I think it's better to start from scratch and design something purpose built for these cells. It's just, I just don't want to take any risks with charging as well. I want to have proper cell monitoring so that I can shut down a charger if a cell goes too high or if a cell goes too low. I want to open the contactors if the cells go too low so that you can't continue discharging. Yep. Okay, that's pretty much everything for now. I've got to get this certified soon, but until then, I will see you later.